So in the previous lecture we have obtained result for pre-stress and bending pre-stress, and now in this video we are going to obtain result for resultant stress at any section, and this is due to some externally applied loads like dead load or live load. So the beam is pre-stressed and there is a uniform direct pre-stress, that is P by A. This is direct pre-stress, and bending pre-stress is P by ZB or ZT. ZB on bottom and ZT is at the top. So these are pre-stresses, and this is direct pre-stress, and these are bending pre-stress. Okay, now we are going to apply some loads on the beam, and we will find the result, that what is the resultant stress at any section. So first we draw a beam like this. This is our beam. Okay, this is the neutral axis. And the pre-stressing is done eccentric. So this is wire or tendon which is at a eccentric distance E. Now this we have done till this part in the previous video. Now we are going to this pre-stressing force P. Now we are going to supply some uniformly distributed dead load or live load. So let us assume that our dead load intensity is represented by Q, and live load intensity is represented by G. So due to this, if we assume this UDL as dead load, then like any RCC this is like RCC member or concrete member. If we are applying some UDL, then it is going to bend. It is going to bend and bend like this, sagging bending moment. So same case here also, this dead load intensity is going to bend this member into sagging moment. So that moment MQ, moment due to dead load intensity. And for UDL we know that maximum value is WL square by 8. So here W is equal to Q into L square divided by 8. Same for live load mg. We know that the maximum bending moment is at mid span. This is mid span, and maximum bending moment at this section is mg, that is also G W L square by 8. W is equal to G into L square divided by 8. So these are our maximum bending moment at mid span section due to the respective dead load or live load intensity. So these are moments. Now just like we have used that simple bending formula, F bending stress formula, that is F is equal to M by I into Y, or M by I into Y. This I divided by Y is represented as Z, M by Z. So Then bending stress due to this dead load will be m by z. So F Q will be m by z and Fg will be m by z. Okay, but our m is q l square by 8 divided by z. Our m g is g l square by 8 divided by z. Now this fq at the top will be mq by zt, at the bottom will be zb. Same fg will be bending stress will be mg by zt at the top and zb at the bottom. Okay, so if we are going to draw some stress diagram, if this is our section, mid span section here, mid span section here, so this is our section. If we cut this, we obtain this section. Then this is our NA, and the tendon wire is here at eccentricity E. Okay, so we draw first stress diagram due to direct compression, direct bending stress, direct compression, direct compressive stress. Okay, that is not bending stress, that is P by A. This is pre-stress, direct pre-stress P by A. This is uniform at any point of the section or at any distance from the neutral axis. P by A uniform, same value, top, bottom, anywhere. Okay, now plus due to eccentricity we obtain the result of bending pre-stress, and that is PE by ZT and PE by ZB. We have obtained this result in the previous video, and this is negative and this is positive. We have used the sign convention that compressive stress is positive and tensile is negative. So the top above neutral axis, due to bending pre-stress, it is the whole section is tensile, so this is minus PE by ZT, and bottom is compressive. Plus there are other stresses also, bending stresses, like due to these loads UDL, it is Q or G. Okay, so for Q, that is for Q it will be like this. It has giving sagging shape, so this is sagging moment. So top will be like compressive zone plus, and bottom will be tensile zone negative. Okay, and the top value will be m by ZT, and the bottom value will be m by ZB. Top will be MQ. This is dead load, due to dead load, then MQ. Similarly, due to live load intensity also, stress diagram same, plus minus. Top zone is above neutral axis zone is compressive and below neutral axis zone is tensile. So this will be MQ by MG by ZT, and bottom is MG by ZB. So these are stresses. This is pre-stress, direct pre-stress. This is bending pre-stress. These are bending stress due to dead load intensity, and these are bending stress diagram due to live load intensity. So there will be a net, if we add 1 2 3 4, there will be a net resultant stress for this section, and it will appear like this. It will appear like this. At the top will be P by A minus P by ZT plus mg by ZT plus mq by ZT. At the bottom P by A same bottom plus this one P by ZB minus mq by ZB minus mg by ZB, like this. Okay, these are, there will be no negative value because we have to obtain only compressive stress, no tensile, no resultant tensile, because concrete is weak in tension. So lesser value from at the bottom and maximum value at the top. Okay, these are diagrammatic value. If you write this as numerical value, then F superior or F at the top will be P by A minus P by ZT plus mq by ZT plus mg by ZT. F inferior or F bottom, stress at bottom, is P by A plus P by ZT minus mq by ZT minus mg by ZT. So this is our formula, and we are going to use this concept in solving any problem. Okay, we are going to solve any problem. This is our resultant stresses. We can write here resultant stresses. Okay, once again I am going to revise resultant stresses. At the top is P by A, direct compression, direct compressive pre-stress. This is minus P by ZT, this is bending pre-stress, plus mg by ZT, mq by ZT, this is due to dead load intensity, this is going to bend, so bending stress, plus mg by ZT, same bending stress due to live load intensity. F inferior at the bottom, P by A, direct compression, direct compressive pre-stress, plus P by ZT, this is bending pre-stress, P by ZT, minus mq by ZT, this bending stress due to dead load intensity, minus mg by ZT, that is this bending stress due to live load intensity. So we are going to use this concept and these two formula in solving the numerical. So this part has ended our analysis of pre-stress and bending stress. Okay, so in our next video we are going to solve some questions. So so from the previous all the videos you can revise and you can see how we have reached till here. Okay, thank you.